Okay, see Lindelof videos, completing the square. Just gonna make this a super short video, just actually making it to try to help a friend. Just keep in mind that we're using quadratic equations, right? I'm gonna keep this quick, I promise. Quadratic equations. And when you have a quadratic equation, unlike some other equations, it's set up always equal to 0. So it's ax squared plus bx plus c is equal to 0. And these a, b, and c values become really important. And what we're going to do here is we're going to move this c over and we're going to create our own c value. It's super easy. Just stick with me. So it kind of looks like this. So we have this equation here, right? So I always rewrite them, so I apologize. Plus 14p minus 38 equals 0. And when we look at this crap, it's unfactorable. So we tried to use other factoring techniques and we found out this thing kind of sucks. It's unfactorable. So we're going to use this different technique. And it's always easier to do it when the b value is even. And the b value is even, it's a lot easier to use. So that's why I'm going to use this here. First thing I'm going to do is I'm going to get rid of this piece right here so I can set up my new b value. My new c value. So plus 38 here. So look what that gives us. That gives us p squared plus 14p is equal to 38. This works out really good. Now here's the little trick we're going to use. We're going to take the b value. So we're going to take b divided by 2, and then we're going to square it after that, right? So then we're going to square it. And that gives us our new c value. And that's to create this perfect square that we're going to be using. So our b value is 14. And when we get 14 divided by 2, right? And we square that, we get 14 divided by 2 is 7. 7 squared is 49. So that's going to be our new c value. So we're going to add 49 to both sides. And we're going to get p squared plus 14p, right? Because this is 49, it's not 49p, it's just 49. It's our constant value, so we add that to the outside. And I'm going to add this over here, and this gives us, what is it, 87? Gives us 87, right? So if you look carefully, what we've created here is a perfect square, right? So you look at this, and this is what we get by completing the square. This turns into a perfect square, which means this. We're going to get this 7 value right here is going to be really key for us, right? This is positive 7. So we're going to get p plus 7 times plus 7 is equal to 87. And I only show you this, I want to show you this one time, just to show you do get this back. P times p is p squared, p times 7 is 7p, 7 times p is 7p, so 7p plus 7p is this 14p, and then lastly 7 times 7 is this 49. Sorry you guys, I know that was hell to have to hear, but you'll be alright, I promise. So, right, we got p plus 7 squared, right? Anything times itself is that thing squared. So we have is equal to 87. So look, this gets really easy. We're just going to solve. Now I want you to notice here that we have a square here. To undo a square, we use a square root, right? So if you use a square root on this side, remember, you have to use the square root on this side. So here, right, this square root cancels this 2 right here, and that just leaves us with p plus 7 on this side is equal to, this is super important, everybody screws this up, is equal to plus or minus square root 87. If you want to talk about why that's true, we can talk about it at a later time. But this means we have to do this twice because we means here we're going to use positive here, and then we're going to use negative second. So I'm going to start solving. And to solve, I'm going to subtract 7 from both sides. So that gives us p equals, look, I'm going to do the plus part first. Square root 87 minus 7. This is one answer right here. That's the solution. And our second solution is this minus part, so it's p is equal to negative, the opposite of 87, square root 87 minus 7. And I know you're like, damn, Lindelof, that's kind of crappy, didn't work out really smoothly. A lot of times it won't. We're going to see an example in a minute where it does work out perfectly, but these are your two answers. So this is a solution. This is one of your solutions. And this is the other. So solution and solution. Let's try one more. If you're still with me, that's good. Oh, look, this is one that does work out perfectly, and I'll show you what I mean in a second. So we have v squared plus 6v minus 27 pretend we've done all this work and we're like, damn, this thing will not factor. So if it won't factor, then maybe, all right, and this is even, I'm like, okay, this might work. I might be able to use completing the square here. So I'm going to use that. First thing I'm going to do, remember, is I'm going to move this c value over because it's not the c value that we want. So plus 27 here, plus 27 here. And we get v squared plus 6v is equal to 27. Now we start completing the square, right? This is still the b value because b value is the one that's in front of the first degree variable. So I'm going to pull this out, and I'm going to get 6 divided by 2 squared, right? 6 divided by 2 is 3. 3 squared is 9, right? So remember, this is our new c. This is our new c value. So we're going to get v squared plus 6v. Going to add this 9 here. 9 here is equal to, if we added 9 here, we have to add 9 to this side, right? The additive addition property, equality property of algebra, and that gives us 36 here, right? Remember, this is this 3 right here, 6 divided by 2. This 3 right here is really important because it goes in here when we complete the square. We have v plus 3 times v plus 3, otherwise known as v plus 3 squared is equal to 36. Hopefully you can see what we're going to do here. You see the squared here. So to undo a square, you take its square root and the square root here. And we get here, we get v plus 3 is equal to plus or minus the square root of 36. Remember, square root of 36 equals positive or negative 6. So we're going to do this problem twice. Let's do it. First, we're going to do the plus. So we have v plus 3 equals 6. Subtract 3 from both sides. And we get v is equal to 3 is one solution. We'll do it the other way. Now we'll do the negative 6, and that will give us, right, that will give us v plus 3. v plus 3 equals negative 6, right? We already used the positive 6. It's going to subtract 3 from both sides. And we'll get v is equal to negative 9 are our two solutions. So that is a really, really quick lesson on how to do completing the square to find the solutions for quadratic equations. I hope it was helpful. I know it was quick. If you have any questions or comments, please let me know. And if you haven't already subscribed, please do.